Now let's talk about how to implement a secure environment for a database service. We'll review some best practices for securing both on-premises SQL Server databases and Azure SQL databases. You'll also explore a range of security options available in SQL Server and in Azure, including built-in features that help protect data at rest and in transit. Along the way, we're going to gain a deeper understanding of why database security is essential and how to apply the right tools and configurations to safeguard sensitive information in the cloud and in hybrid environments. If you'd like to follow along, please use the URL here on the slide. Specifically in this section, we will focus on what authentication is and how it's different in Windows versus SQL Server versus Microsoft Entra ID. We'll also explore both data at rest and in transit encryption solutions. And lastly, we will implement a data sensitivity solution here in SQL. Our first topic, we will talk about how to configure data authentication and authorization. Azure SQL Database has several authentication options that are different from the authentication options of SQL Server. You'll learn about the differences between those authentication mechanisms here. Our objectives here are to introduce you to the authentication options available in Azure SQL Database. We will also define security principles and roles in Azure SQL Database. And then we're going to take a closer look at the permissions available in Azure SQL and focus on the concept of least privileged permission. Now let's talk about Azure AD authentication options, which is known also as Microsoft Entra ID. As outlined here, we can see that the authentication options available for SQL Server and Azure SQL Database and Managed Instance each offer distinct benefits and use cases. Windows authentication for SQL Server and for Microsoft Entra ID authentication for Azure both leverage centralized identity management through Microsoft Entra ID, providing enhanced security, simplified user provisioning, and seamless integration with enterprise identity systems. This is ideal for organizations with strict access control policies in hybrid environments. SQL Server authentication is available in both platforms, stores login credentials locally in the master database or the user database, and we're going to see that it offers flexibility for legacy applications, isolated systems, or even scenarios where external identity providers are not feasible. These options allow administrators to tailor authentication strategies to meet organizational needs, whether prioritizing centralized security or accommodating specific technical constraints. A common question often asked is, what is the difference between Microsoft Entra ID and Windows Server Active Directory? This is especially confusing for new admins because Microsoft Entra ID interacts with Active Directory. Both solutions provide authentication services and identity management, but in different ways. Active Directory uses a protocol called Kerberos to provide authentication using tickets, and it is queried by the Lightweight Directory Access Protocol, or LDAP. Microsoft Entra ID uses HTTPS protocols for authentication like SAML and OpenID Connect for authentication and uses OAuth for authorization. Active Directory is designed for on-premise infrastructures, providing Windows authentication for SQL Server by managing user access through domain-based credentials. This is ideal for organizations with centralized internal networks and strict group policy controls. In contrast, Microsoft Entra ID is built for cloud environments and integrates seamlessly with Azure SQL Database and Managed Instance, enabling users to authenticate using their cloud identities. It also provides no object hierarchy. Put simply, authentication is the process of proving who you are to Microsoft Entra ID in the Azure cloud or Active Directory on premises, while authorization is the process of once you've proved who you are, what are you allowed to do, what permissions do you have. Identities are users service principals or computers, or more, for example, both on-premise SQL Server installations as well as SQL Server installations within Azure virtual machines, they both support two modes of authentication: SQL Server authentication and Windows authentication. While using SQL Server authentication, both SQL Server specific login, name, and password are stored within SQL Server, either in the master database or, in the case of a contained user, within the database itself. And then using Windows authentication, users can connect to SQL Server using the same Active Directory account they use when they log into the computer, and they can also use that same account to access file shares and applications that they're authorized to use. This slide demonstrates how to configure Microsoft Entra ID, formerly known as Azure Active Directory, for Azure SQL Database and for the managed instance. We can see highlighted here its role in a secure cloud-native authentication. Microsoft Entra authentication functions very similar to Windows authentication. In a traditional SQL Server deployment, it offers integrated identity management and support for multi-factor authentication, or MFA. To enable this, administrators must first configure a Microsoft Entra admin, which establishes the link between the SQL resource and the identity provider. Once this is set, organizations can enforce Microsoft Entra-only authentication, ensuring that only users authenticated through the Entra ID can access the database. This enhances security and simplifies access control. This setup is especially beneficial for enterprises adopting hybrid or cloud-first strategies, as it supports single sign-on, or SSO. It also offers centralized user management, and it's integrated with governance tools like Microsoft Purview. So use cases for this could include things like secure remote access for distributed teams, compliance-driven environments requiring policy-based access, and organizations seeking to unify identity across cloud services and data platforms. Now let's take a look at the foundational components of SQL Server security: securables, principals, permissions, and security hierarchies. And what we can see here is that emphasizes how each plays a role in protecting data and managing access. Securables are the objects that require protection, such as databases, tables, stored procedures, and the like. The best practice here is to classify them by sensitivity, like high, medium, and low security, and apply appropriate access controls, like restricting financial data to authorized roles. Principals are the identities that interact with the securables, and they vary by environment. In Windows on-premises setup, principals include domain and local users and Windows groups. In Microsoft Entra in the Azure cloud, they include users and groups. And in SQL Server, principals include logins and server roles. And at the database level, they include users, database roles, and application roles. Assigning permissions to roles rather than individuals simplifies management and supports the principle of least privilege. Permissions define what actions principals can take, such as select, insert, or execute, and more, and should be regularly audited to prevent overprivileging. Finally, security hierarchies help organize securables and principals into nested structures, allowing scalable and maintainable access control. For example, an HR manager role might inherit permissions from both employee and manager roles, streamlining access across multiple layers. Here, security principles help us explain the foundational elements of identity and access management in SQL Server and in Azure SQL environments. First, let's define a security principle as any login, user, group, or role within a server or a database. These are the entities that can be granted permissions to access securables. Here we see two types of database users, those mapped to a login at the server level, and contained users who exist only within a specific database. Contained users offer a lot of flexibility and can be authenticated using either SQL Server authentication or Microsoft Entra ID, making them especially useful in cloud-native or hybrid environments. Lastly, our final point here emphasizes best practices in permission management. Rather than assigning rights directly to individuals, it's recommended to map users to roles, allowing for centralized and scalable access control. This approach simplifies administration, reduces errors, and supports compliance. Here we see how access control is structured within SQL databases, focusing on the concept of securables and schemas. Securables are the resources within the database, as we mentioned before. There are things like tables, views, stored procedures, and more that require controlled access. These are referenced using a hierarchical format, which is server.database.schema.object. which helps precisely identify and manage permissions for each object and organize your resources. Schemas act as containers or namespaces that group related objects together, making it easier to organize and secure them. For example, HR-related tables might be placed in the human resources schema, while sales data could reside in the sales schema. In Azure SQL Database, the scope of securables is limited to the database and the schema levels, simplifying the hierarchy compared to on-prem SQL servers. Best practices here include assigning permissions at the schema level to reduce complexity, using consistent naming conventions for clarity, and regularly auditing access to ensure compliance. This structure supports scalable, maintainable, and secure database environments across both cloud and on-prem deployments. Now let's look at how SQL Server and Azure SQL Database handle authentication and user creation, focusing on the distinction between instance-level logins and contained database users. So regardless of the authentication method, whether SQL Server authentication, Windows authentication, or Microsoft Entra ID, a login must first be created at the instance or server level, stored in the master database. To grant access to a specific database, a corresponding user must be created within that database and mapped to the login. For example, this can be done using T-SQL's create login statement at the instance level, and create user from login to map the login to the user database. Alternatively, contained users are created directly at the database level and do not require server level login. These users can be based on SQL Server authentication, Windows authentication, or Microsoft Entra ID, depending on the platform that you're using. To enable this, the database must be configured for partial containment, which is enabled by default in an Azure SQL database and optionally can be set in a SQL Server. A contained Microsoft Entra user is created using the from external provider T-SQL syntax. Best practices include using contained users in cloud-native environments to simplify identity management and support modern authentication features. Use instance-level logins where managing centralized access across multiple databases or when integrating with traditional non-premises Active Directory. SQL Server and Azure SQL Managed Instance provide a set of predefined fixed server roles. These grant specific server-level permissions to server-level principals such as SQL Server logins, Windows accounts, and Microsoft Entra IDs. These roles cannot be modified, but you can create your own custom server roles using the Create Server Role T-SQL statement. However, server roles cannot be granted access to database objects directly. They manage server-wide permissions only. By using roles, administrators and auditors can more easily manage and review access, ensuring security and compliance across environments. The roles help delegate administrative tasks securely and efficiently. For example, bulk admin allows users to run bulk insert operations. This is useful for data engineers importing large data sets. DB creator can create, restore, and drop databases, which is ideal for DBAs provisioning new environments. And disk admin manages backup devices. Roles like process admin can terminate SQL processes, while security admin manages logins and should be treated with the same caution as system admin, which has unrestricted access. Server admin can change server-wide settings and shut down the server, and setup admin manages LinkedIn servers. The public role is assigned to all logins by default, and its permissions should be carefully reviewed. Managing database security can become complex, especially in applications with many users and varying access needs. To simplify this, SQL Server and Azure SQL Database support role-based access control, or RBAC, a widely adopted model where permissions are assigned to roles, essentially security groups, rather than to individual users. This approach allows administrators to define roles such as administrator with full access, reporting user with read-only access, or application accounts with write access, and then assign users to these roles as needed. Both platforms include built-in roles and allow the creation of custom roles at the database level and in SQL Server and in Azure SQL Managed Instance, also at the server level using Create Server Role T-SQL syntax. SQL Server and Azure SQL Database include a set of built-in database roles that simplify permission management by grouping common permissions into predefined roles, making it easier to assign access based on job functions rather than individual users. These roles support role-based access control, or RBAC, which is a widely used model that enhances security and maintainability. For example, DB owner has full control over the database, including configuration and maintenance tasks through Azure SQL Database, and some actions will require server-level permissions. So roles like DB Data Reader and DB Data Writer provide read and write access to all user tables, respectively. DDL admin allows execution of schema altering commands. Administrative roles such as DB Access Admin manage user access, and DB Security Admin can modify role memberships and permissions, though this role should be monitored due to its potential for privileged escalation. For backup operations, DB Backup Operator is used, and restrictive roles like DB Deny Data Reader and DB Deny Data Writer explicitly block read or write access. In Azure SQL Database, special roles in the Virtual Master Database, DB Manager and Login Manager allow database and login management respectively, similar to server-level roles in SQL Server. These built-in roles provide a structured, scalable way to manage access across diverse database environments. Here is an overview of how permissions are managed in SQL Server and in Azure SQL Database, emphasizing the importance of fine-grained access control for securing data and operations. Permissions can be applied to various database objects such as tables, views, stored procedures, and function. For tables and views, data manipulation language or DML permissions like select, insert, update, and delete control who can read, write, modify, or remove data. These permissions can even be restricted at the column level, and row-level security can be used to limit access to specific rows based on user identity. Please note that this is a best practice to not give select permission on a table, but to use a view for the user to use the view to see the columns and fields in the table that you'd like them to be able to see. For stored procedures and scalar functions, permissions such as execute, alter, control, and view definition determine who can run, modify, or view the code behind those objects. It's a best practice to use stored procedures for your transactions. Additionally, data definition language or DDL permissions like create, alter, and drop govern schema changes, while data control language or DCL permissions, grant, deny, and revoke, are used to assign or remove access rights. Special permissions like references, take ownership, view change tracking, and control offer even more control over object behavior and metadata. In practice, permissions can be managed through SQL Server Management Studio or SSMS by right-clicking on a database or a table and navigating to the Permissions tab. Best practices include granting permissions through roles rather than directly to users, and using the principle of the least privilege permission, and regularly auditing access to ensure compliance and security. Here are some foundational permissions and principles for managing SQL Server and Azure SQL Database, emphasizing that permissions can be assigned to both individual users and roles, which supports scalable and maintainable access control. So permissions are additive, meaning a user's effective access to the sum of all permissions granted through their roles. However, a deny permission will always override a grant, ensuring that explicit restrictions take precedence. These permissions can be applied to various database objects like tables, views, stored procedures, and functions with granular control, including column-level access, row-level security, and advanced permissions such as control, execute, view definition, and references. Administrators can manage these permissions through SQL Server Management Studio, again by right-clicking the database or the object and going into the Permissions tab, or you can do it, of course, through T-SQL. Here we see a demo on how SQL Server handles permission conflicts, specifically showing that a deny statement overrides a grant. The example begins by granting the select permission on the dbo.company table to a user named demo, but then immediately denies that same permission. When the session impersonates the demo user using execute as user demo and attempts to run a select query, SQL Server returns an error message indicating that the select permission was denied. This illustrates a key principle in SQL Server security. Deny always takes precedence over a grant, even if both are applied to the same object and principle. Best practices here include avoiding unnecessary use of deny unless explicitly required for security, and managing permissions primarily through roles to reduce complexity and prevent conflicts. The execute as user or execute as login, they're only available in SQL Server and Azure SQL Managed Instance. These commands allow for a user context to be changed. A subsequent command and statement will be executed using the new context with the permissions granted to that context. Execute as user is to be used to change the context of the database user to another database user, while execute as login should be used to change the current login to another login to test it. Always consider granting the least privilege permission when you use these commands. Here we see how SQL Server handles permission inheritance between database objects based on their ownership. In SQL Server, when a user accesses an object like a view that references another object such as a table, permission chaining allows the access to succeed without requiring explicit permissions on the underlying object, but only if both objects share the same owner. The diagram shows that user 1 has access to view 1 and view 2. Both are owned by user 2. View 1 successfully accesses table 1, which is owned by user 2, thanks to the ownership chain. However, view 2 fails to access table 2, which is owned by user 3, because the ownership chain is broken. This concept is crucial for designing secure and efficient database architectures, as it allows developers to encapsulate access logic in views or procedures without exposing direct access to base tables, as long as ownership is consistent. Best practice includes aligning object ownership when designing dependent objects and using ownership chaining to simplify permission management while maintaining security boundaries. Dynamic SQL is a technique in SQL Server where queries are constructed programmatically and executed at runtime. It's particularly useful for scenarios requiring flexible or data-driven command generation. The example shown dynamically builds backup database statements for each database on a server by querying the sys.databases system view and concatenating strings to form complete backup commands. This allows administrators to automate repetitive tasks like backing up all databases without having to hard code each command. Dynamic SQL is powerful for tasks such as generating reports, managing schema changes, or executing conditional logic, but it should be used carefully to avoid SQL injection risks and to ensure maintainability. Best practices include validating inputs, using parameterized queries when possible, and limiting the execution scope to trusted contexts. The principle of least privilege is a foundational concept in database and application security that ensures users and applications are granted only the permission necessary to perform the required tasks, nothing more. By limiting access, organizations reduce the risk of accidental or malicious actions that could compromise data or system integrity. For example, if an application accesses data exclusively through stored procedures, it should be granted only the execute permission on those procedures, without any direct access to the underlying tables. This approach not only strengthens security, but also simplifies auditing and compliance. Implementing least privilege effectively involves carefully analyzing roles and responsibilities, assigning permissions through roles rather than individuals, and regularly reviewing access to ensure it aligns with the current operational needs. Here we highlight 3 common error scenarios in Azure SQL environments and provide recommended actions to resolve them. One issue is login failures, which may be caused by service outages and should be checked against the Microsoft Azure Service Dashboard. Resource limit errors can occur when a database exceeds its compute or storage capacity and requires proactive monitoring to avoid transient failures. Lastly, the extended authentication failure may indicate deeper connectivity issues and should be escalated via an Azure support request if they persist beyond 60 seconds or it recurs frequently. These guidelines help administrators quickly diagnose and respond to access-related problems, ensuring secure and reliable database connectivity. Now it's time for our knowledge check. Which protocol is used by Microsoft Entra ID for authorization? Answer: OAuth. Question 2. What feature allows a user to execute a stored procedure even when she does not have permission to access the tables referenced in the stored procedure? Answer: ownership chaining. And then question 3, which role allows users to create users within a database? Answer: DB access admin. Now it's time to take a look at how to authorize access to Azure SQL Database with Microsoft Entra ID. Now join me in lab number 3, Authorize Access to Azure SQL Database with Microsoft Entra ID, and we're going to start off in the Azure portal. And as we've done in most of our labs here so far, we actually have Azure SQL available here to use, and we're going to start off by using that. So remember, if you don't have Azure SQL here, you can go up to the top in search and you can type it in to get access to it. And what I'm going to do is I'm going to set up for server administration, and how that is done is actually done at the database server layer. So I'm going to use one over here on tab 2, and I'm going to use DP-300 lab 1 as my database server. And we'll see right here in the window that we have Microsoft Entra ID admin. So whoever is listed here is the server admin for SQL. And if I want to change that, I can click on it. And in the second window, I can choose Set Admin. And then I can go find a user on our list here that I would like to make the admin. Now, it's a pretty good idea to do a group. So maybe what I have is I have this DBA group that I want to use since I've already created it here in Microsoft Entra ID. And in that group, you have additional people. Maybe you know a couple of admins are located in that group. And then you could assign the DBA group as the admin for SQL. And this would be the preferred way to do it. So once you've set that in, you can go select it, and then you come back here, and this will be darkened in, and you can save it. And you can change the admin very easily. And if you need to be able to do that, you want to do it initially right out of the gate. Have an admin set up to manage SQL. Okay, so this is part of it. The other thing I'm going to do is I'm going to connect to the management studio where I have it open right here. And in the management studio, you can see that we can connect, and I already am connected, but I'll show you how I did this process here. I connected to the database engine, and when the window opened up, what I did is I pasted in the server name of the server, and that's the DP-300 Lab 1 that we just took a look at out here. So if I need to, I can grab the server name from right here. It's actually just right there. I can copy it in. And so that database server on the overview blade, I can copy the server name right from here. Once I do that, I can pop that into the window and use my username and login. So I have an account there in the Azure SQL Database server to be able to do this. And this is, we'll note here, I can just adjust and use the Microsoft Entra ID MFA. There's other options you can use. We then want to trust the certificate, and I can connect to this. And then on the right-hand side, or actually the left-hand side, and you can see that I'm connected to my Azure SQL Server with the databases. And it has a couple of databases on it. As you can see here, I'm going to use the AdventureWorks just AdventureWorks LT 2. So I'll use that as my database, and I'm going to go to make some contained users. So I'm going to open up a new query window here, and I'm going to go ahead and paste in from the lab that we're working on, the syntax here, to create some users at the database level, DP user 1 and DP user 2. These are going to be contained users, and I'll execute this. And I make certain before I do that I'm on the right database. And I want to add these, and then I'm going to see that they're actually there. So I'm going to go to Security and into Users. And I don't necessarily see them right away, but I have to refresh, and then they should hopefully come up. And there's User 1 and User 2, contained users. There's the passwords there, so it's not that secure as you can tell. And what I'm going to do is I'm going to add them to roles. So I'm going to go make a role called Sales Reader. And then I'm going to go add in both the DP-300 user 1 and 2 to that role. So we'll execute that, and then we should note down in roles that we have the roles created. The role is there with the users added. So again, I don't see them. I just need to go and refresh it here. And we should see sales reader role. There it is, right there. Okay, so we'll zoom in over a little closer so you can see the role has been added. And then the database role is at the very bottom of our sales reader there. So we've added the roles, we've added the users. Now we're going to go in and use a stored procedure here. And I'm going to go back into the new query, and I'm going to go ahead and I'm going to make certain that I'm on the right database there. And I'm going to paste this in, and I'm going to create a stored procedure called sales. And in this, it's going to be in this schema called sales LT demo proc. It runs a select statement doing a join between a couple of tables, 3 tables there. And then I can see 4 tables. And then you can see that this stored procedure, when we run it, it's going to run the query on the 4 tables. So we have the stored procedure created. And we like, there's other stored procedures here. If you want people to be able to use them, you have to give them permission, of course. So note that when I run this next query, what I'm going to do is I'm going to execute as another user to kind of test this out. I'm currently logged in as admin for this server, but I'm going to try to test this out as one of my DP-300 user 1, which is something you definitely want to do. Test these out, make certain they work. And you can see that what we've created, and we're going to test this out. So I want to execute the stored procedure. And before we do that, let me go find the stored procedure. That stored procedure should be under stored procedures here. And what I'm going to do is I'm going to refresh this and see if we can see it. So there is our demo proc right there, and it's under the sales LT schema. So let me execute this and see what happens. A little bit of an error. And the reason is it's just because you have your user on the database, you can't do everything. So what I'm going to do is I'm going to revert this. And since I'm executing as user, I still essentially am that DP-300 user. So what I'll do is I'm going to revert back to me, and then I'm going to grant permission on the schema to sales LT, to the sales reader. Now this might be, as you know, I want to go back here, and then I have to have the ability to grant and execute permission on the schema, and I'm going to grant it to the schema sales, and then I'm going to also make certain that the accounts inside of it will get the same permission. I'm going to grant execute to it. So execute, as you may remember, is given to a stored procedure, but it can also be given to a scalar function and a few more different objects that are out there. But these are 2 that are the most popular to use. And I'm going to go ahead and grant execute. And remember, we want to consider least privilege permission when we set this up. So I probably should have instead been using one of the other examples here that's at a smaller scope. And you could have been more specific and said grant execute to the stored procedure here. And that's not everything in the the sales LT schema. So we have to think about least privilege permission. So once this is granted, then what I'm going to do is I'm going to come back here and I'm going to go ahead and re-execute this command, which I think I have at the top here. So let me execute this one more time, and yes, there it is. So I was able to run it now as DP-300 user 1, and the Management Studio can work with these contained user accounts. But if your contained user is actually someone from Azure, we have to take a different approach to it. Can we make someone from Azure a contained user? Well, I'm going to test this one out right here. I have this filler name in here that I'm going to use, and I'm going to go out to Azure again. And I'm going to go out and take a look at our Microsoft Entra ID here. And I'm going to find a user from our list to use. And I'm going to go ahead and find that I have DP-300 user 3. I'm going to copy their information. And I'm going to go back into the Management Studio and I'm going to paste it in over that placeholder right there. And when we do something like this, I'm going to make a user in the database is what I'm going to do here, a contained user in this database that's actually from Azure. So take a look at that syntax. I have to say from external provider since I'm getting this account from Azure. And I'm going to go ahead and execute that. And once that's executed, I should find that user right here in our list. So we can make them here in the Management Studio, contained users. We can also make them by pulling them in from Azure. Now I want to take this a step further, and I'm going to test the DP-300 user 1 there in Azure itself. So I'm going to come out here, and I want to see if I can run some queries from in the database. So I'm going to go find our database L2 right there. So the AdventureWorks LT2. And when I get into that database, I'm going to go into the query editor. And I'm going to try logging in with that user. So let me pick this up again, their name, make certain I have the name of that user and the password. So I need to know both of those to test this out, the name and the password. And I'll go back in here and I'll paste that login there. And I may have used it earlier, so there's the password. And I'm going to just verify that I have the right password. It's that Azure password there. Then I'm going to click OK. And it looks like I'm able to go in and only access really that stored procedure, that sales LT demo proc stored procedure. And anything else I have access to, I'd be able to see here also, just a few things. Remember, we put the permission on the schema sales LT, which probably isn't the best way to do this. The better way to do this would be to really put the permission on the actual object itself for at least privilege permission. And so I was able to add my contained users here inside the Management Studio and also in Azure. Thank you for your time and attention in this optimization section. I look forward to seeing you in the next.